Guys, welcome to my channel. In this let's see what are the convolution codes. So basically it is a type of error correction codes that generates parity symbols via the sliding application of boolean polynomial function to a data stream. Okay, basically this is also a one type. Basically in the at the previous videos we saw that there are I think that some video I have told that there are types of codes, two types. One is block code and another is convolution code. The block about till above those are all called block codes. Now we are seeing what is a convolution code. So convolution code is also a type of error correcting code only. So what is the difference between the block code and this? Is in a block code a block of n digits generated by the encoder in the particular time unit depends only on the binary block of the k. Generated by the encoder in the particular time unit depends only on the block of k input message digits within the time unit. In convolution code, a block of n code digits generated by encoder in the time unit depends on not only on the block of k message digits within the time but also on the preceding n-1 blocks preceding next n-1 blocks of message. So basically what he is saying is, in a block code what we are doing, in a block code we are only considering only n digits generated by the encoder in a particular time unit only on the depends only on the k block of k inputs, right? That means basically n and k only it is depending, but in convolution code what and all it is depending it is depending on k bits along with also on n minus blocks of message also. That means, so when you take here in general I will tell you what is the dependence here. Wait, I'll tell you after this. Okay, so like block codes, convolution codes can be designed to either detect or correct errors. However, block codes are better suited for error detection and convolution codes for error correction. So basically what they are saying is block codes is used better to use for only, like we are using for both, right? But it is more best way to use block code is to only for error detection only. The best way used to convolution code is for error correction. Okay, for error detection block codes, error correction is convolution. But in general we can do both in like correction and detection in block and convolution as well. Okay, encoding of convolution codes can be accomplished using simple shift registers and several particular by using simple shift registers and several practical procedures having been developed for decoding. So either we can use we'll be using simple shift registers and some practical procedures for decoding. Okay, so encoding of conventional codes. So basically what happens, this conventional encoder, when a message block is sent through a conventional code, it will generate a code block as same as code block only, code vector block code only. So if you send k message bits into a convolution encoder, we will get n bit code block, because n minus k bits of parity will be, or the redundant bits will be added to the code, right? That's why it will be generating n bits of code block. So the n digit code block depends not only on the k digit message block of the same time unit, but also on the previous m-1 message blocks. The code generated by the above encoder is called as n, k, m convolution code. So we'll get a better understanding when we proceed forward what is n, k, and m. Okay, here the n and k is not message block. Okay, we'll see what is n, what is k, and what is m in the next like continuation of the session. Now let's for the constraints. So to find the constraint length, that is n m digits. Okay, here the n comma k comma m convolution code of constraint length nm digits and a rate efficiency k by n. Okay, these are two things. If they ask what is the constraint length, we will just multiply n and m, and if you ask what is the rate efficiency, k by n. The parameters of the encoder n, k and m are in general small integers, and the encoder consisting of shift registers and modulator adders. So in previous block, what is the values of n and k? 7, 4, like that is, here it will be small, 2, 2, 1, 2, 3, 1, 3, like that only, simple ones only will be there. Okay, so here what we are doing here, an encoder of n comma k, that is 313 convolution code, explain the operation of encoder and hence obtain the output of the encoder. Actually, what is the question they will give is, until this diagram they will give in the question. Okay, this diagram will also be given by the examiner only. Sorry, so in the questions they will give this diagram will also be present in the question only. Okay, now what we need to do, we need to draw the timestamp. Here the time is like from 0 to tb to 2 tb, 3 tb, 4 tb, 5 tb, 6 tb, 7 tb, because what happens here is up to 5 tb. See, I will tell why up to 7 tb. We'll see how we got that. Here initially there will be, what is the diagram is, there will be flip-flops here. This one d1, d2, d3, 3 flip-flops, and those are connected to these modulo 2 adders. Okay, first what happened, basically the data will be entered one by one. Initially these flip-flops will be initialized to 0, all will be zeros only. Okay, so I will take one thing, do this page. Paste. So here let us take here the data, let us take the data input is 10, here 10111000. So the data also will be given in the question, don't worry what is the data also. So 1011100. Okay, so basically this is the data. The first, this one is called d1, d2, d3, d4, d5, or wait, d1, d2, d3, d4, d5, d6 and d7. Okay, totally 7 bits are there. Now what happened, each bit will be sent. First d1 will be sent, next d2, like this only it will go. Okay, from d1 it will go. So first d1 will be sent into here. So initially all zeros are there, no? So first when d1 is 1, the cap here this first flip-flop will be 1 and the remaining will be zeros, right? Because only one bit is sent here. So d1 will be filled with 1 and d2 will be 0, d3 will be also 0. So what happens, first 3 blocks, because the size is 3, because there are 3 flip-flops like this, so that's why these 3 will be 1 0 0. Okay, so what is the value of c1, c2, c3 when it is d1 is 1, d2 is 0, d3 is 0? When you do XOR operation, c1 will be 1 for this one is d1 XOR with d3, that is 1 and also 1. So basically we got 1 1 1 as an output when you sent 1 as the first bit, the d1 bit into this circuit. Now when I send as the next, what is the d2 I will send, right? I will send d2, wait, so now I will send d2, d2 is 0. So when I send d2, what happens, this one will be shifted here and it is 0, 1 0, right? The new sequence. So basically this whole sequence will be 1, because basically the whole sequence will, I am just shifting this, right? First it should be 1 and I have shifted to here, that's why here it is 1. Okay, now that 0 is shifted to here, so that it becomes 0 0 1 1. Okay, from here it is 0, the value in this is 1 and this value will be sent here, so 0 1 0. So now doing the operation for this 0 1 0, we got as 1 0 1 1 0. Wait, I'll do one thing. 1 0 1 0 1. Okay, these are the outputs. So when I send the second bit, so now after this I will send the third bit. Okay, I will send the third bit here. Okay, now if I send the third bit, what happens? Wait, when I send the third bit, what happens? This will be shifted here, this will be shifted here, and the third bit is 1 and it will be coming here. So what is the value? D1 will be 1, D2 will be 0 and D3 will be 0. So 1 0 0 will be there. See in the boxes. So 1 0 1, sorry, D3 will be 1, right? Because this one will be shifted to the D3. So this one is sent here, this 0 is coming here, this one will come here. So basically you need there is no confusion. Once you write the first one, you can see how to write. So how to write is generally 1 0 0. Now we will shift this and the next bit will be coming in the front, like that. So this 1 0 0 is there. So what happens? 1 0 0 will be doing XOR operation here. So this XOR operation will be the C1 will be, what is the output here? C1 will be 0 1 and 1. Okay, so 0 1 1. So this 0 1 1 we wrote here. Now again the next input. So what happens? In the next, what is 0 1 1 is the, now the, okay, so now what are the values present in this 1 0 1, right? So now these values will be moved here, this is moved here, and this one bit will be sent here. So basically the values here is 1 1 0 now. So now the values are 1 1 0. We'll do the same method and we got the values as 1 0 1 0. The same way we'll write for all these. After we need to do this for all these bits. Okay, all 7 bits we'll do. So basically you need to do the shifting as 7 times. 1 2 3 4 5 6 7 times we'll shifting. Okay, these are the outputs for each bit. So when you see the D1 is influencing first 3. Okay, that's what is n minus 1 I told you, no? So total n minus 1 is what? Here n is 4. So what is the n? N is 3 and 3 minus 1 is 2. So along with this 2 preceding, so these 2. If I take D2 is this initially 2 preceding these 2. So total these 2 will be, D2 influences these 3 blocks, and again D3 influences these, like that. Okay, you understand, right? So basically when you observe here, the total length of this block is what? 9. How? Because 3 bits in each, right? So 3 3 3 is 9, like that, 3 bits. So basically we can say directly that 3 into sorry, that is nm. Okay, sorry, we wrote that, and constraint length is n into m. Here n is 3, m is 3, 3 3s are 9, we got, right? So same way, and also that's the same, that is the constraint length is this one. Okay, 9 bits will be there for each influence. So each block will influence 9 bits. Okay, so D1 will influence, this first bit will influence 9 bits, second bit D2, that is also influencing 9 bits, like that. So this is the way we'll do. Okay, now coming to what is the notation. N comma k comma m convolution encoder. N is called number of outputs or the number of modulator adders in the circuit. When you see, it will be matching. N is 3, right? 3 modulator adders are there. And when come to k is the number of input bits entering at a time. Like only one bit is entering, right? So that's why k is 1. At a time we are only sending one bit inside. That's why it is k is 1. And what is m? Number of stages of shift registers or number of flip-flops. So total number of flip-flops is 3 right here. Okay, like basically for a input, for a given input, these 3 will be there. Okay, for example, there is another input, and only for in the same diagram there is another input, or I will show you the diagram, then it will be fine. So let us take this as an example. In this example, it is written as 3 2. Okay, 3 2 and 1, right? Here 3 because total number of what you call modulator adders are 3, that's why 3. 2 because 2 inputs are there. Okay, and 1 because why 1? In the diagram you can see 2, but I am writing only 1 because one input is influencing only one flip flop. That means when you connect 1, it will be, the set is like this only. When you connect second, the set will be different. For each input there is only one flip flop is present. If there is one more flip flop, then we will say 2. Okay, like that. You understand, right? So the number of stages of the number of flip flops, and m is the number of flip flops. So here the number of flip flops are 3, that's why 3. And also I told you, for a particular input we need to see. So L, the number of bits in the message sequence. So here not k is not the number of bits. Okay, number of bits in the message, that L is the number of bits in the message sequence. Okay, so constraint length is mn, and the rate efficiency is k by n. Now what we will do, we'll just give the input to the circuit. Also they will give, and there 2 outputs are there. So we need to find or we can find what is the constraint length, right? M cross n. So for this, how to find m? So n comma k comma m. N is the number of address, that is 1. Okay, sorry, 2 modulator address, 2. Number of input is given is 1, not actually at a time, basically 1, and again 2 because there are what you call, say, number of flip flops. Basically we can write in another way, that will be fine, I guess. Okay, so basically actually it should be 3, but the outputs they're getting is only 2, no? So we wrote only 2 here. So it's using a 3-bit shift register. So in general we can write this m as number of outputs also we can write. Okay, those are so 2 1 2. And now coming to here n is 2 because total adders are 2, m is 2 flip flops, and 2 outputs basically. and then k is 1 because one input is giving at a time. So for that, what is the code rate? That is k by n, that is 1 by 2. For a single input bit, we'll get 2 encoded output data bits. So basically the rate efficiency, rate efficiency or code rate is the same thing, right? Okay, fine. Now coming to the encoder of a how to encoder of a convolution code using the time domain approach. So how do we solve this? So basically here they have given the 212 encoder and the circuit is given. Find the output of the input sequence they have asked. So in this input sequence we can see that I feel like this is wrong. 213 might be 213, I think. According to this, it should be number of flip flops, no? So it might be 213, I guess. I'll let you know. Okay. So now coming now coming to here. Wait. I'll let you know. Okay, coming to problem here. This is the how to encode it. Okay, encoder of convolution code. So they have given what 21, that is n is 2, k is 1, and m is 2, and what is the input sequence is also given 10011, and one more sequence is 11011. We need to find the what is the code vector here. So basically code over here. So basically the circuit is given like this. So what happens initially, the length of the code word you need to find in the both the outputs when the C1 is connected to the top and C2 is the when it connected to the bottom. Okay, so basically it will be the same. Okay, here the output will be the same, that is 1 to L plus M. The formula is how to find this is 1 to L plus M. L is 5 and M is 2. So how 5? Because basically the total, right? So L is the total length of the bits, that is 5, and what is M2? So total is 7 bits. Okay, here the C, what is the 1 2 3 4 5. So total the data is of 5 bits, that's why L is 5 plus 2, that is 7 bits. So same way for C2 also it will be 7 bits only. Now what you need to find, that's the size we found. Now you need to find G's. Okay, G is the output when it is connected on the top one, that is, let us take this is as 1 and this is as 2. When it connected to 1, the output is connected to 1, the output is G power 1, and not G power 1, basically G superfix of 1, the notation, that is a notation, that's it. So this is G power 2. Okay, so now for G1, G power 1, what are the values we will get? That one input is M1, here is M2, M3. So what happens? This commutator will be taken, one is M1 plus M2 plus M3. These are the three values that is present over here, right? So what we'll do, all that, so 1 1 1 we wrote. Okay, when it comes to the second, that is G2, this line, this is the second modulo to adder, only M3 and M2 is connected. So 1 M2 is not connected, so 0, M3 is connected, 1 1 0 1 we wrote. So now what you have to write is, to write a G matrix here, we need to write corresponding columns. You see, we need to pair each one. So 1 1, so 1 1 1 0 1 0 1 1 1 1, like that you need to write. Okay, when you try to write this G. So commutator always connects upper one first and the lower one first, because what happens, first it will be, when it is in G1, the first bit is 1, right? It will connect here and automatically it will come to down. So in the down, what is the first bit? Again 1. So 1 1, it is the sequence. Basically we wrote like a pair, but in actually it will be like normal one only, 1 1 1 0 1 1. Okay, 0 1 1. Now this is the thing we will get as G. So this G, now what we need to write first, we need to find the code, right? So for input sequence you need to write vertically like this, 1 1 0 1 1. G will be writing like this. For 1 into this 1 1, 1 into 1 1, 1 into 1 1, 1 into 1 1, 1 into 0 is 0, 1 into 1 1, 1 into 1 is 1. Now we need to shift by 2 bits. So how many flip-flops are used? 2, right? So 2 bits. So I have did this place and left this place, and now from here we need to start normal, like how you shift and do the multiplication part. Same way, this is we left 2 places, and here from here we need to write. So 1 into 1 1 is 1 1, 1 into 1 0 is 1 0, 1 into 1 is 1, 1 into 1 is 1. So again we need to shift close this, shift by 2 bits, additional 2 bits. Okay, again 0 into 1, sorry, not this one, 0 into here, sorry. So 0 into 1 0, 0 into 1 0, or everything will be 0 0, again 2 bits. Like that we'll multiply everything, and what we'll get like this. So we need to do bitwise XOR operation. So 1 1 here, 1 plus 1 XOR 0 is 1, 1 XOR 1 is 0, 0 XOR 1 is 1, 1 XOR 0, so 0 into 0 XOR 1 is 1, and 1 XOR 1 is 0, like that. So like that everything will write. This is the required for. Same way for the second data also will write. Okay, this is the code vector for the second bit. Why we have used it for both data only 1 1 0 1 1 1 0 1 1? Because we have wrote from generalized way, right? This is the generalized from M1. We thought it is M1 M2 M3, and then we wrote. So this is how we'll do convolution. Now coming to another method called convolution code only in matrix method. So in matrix method, how to solve is, so basically the number of rows in that the generator sequence of top adder and bottom adder can be interleaved and interlaced and arranged in a matrix form. Okay, so basically how to write. So basically this is the same. Here see, we already found that same thing only. Here we already found a generator matrix, that is, so not generator, G matrix. Here see, this matrix can be written as 1 1 1, right? 1 0 1. This is the G matrix. That's what we will do here also. Here what we will do, wait. So first in this question, what are the terms? Let's see. The number of rows will be number of digits in the message sequence, that means L, number of message bits. Okay, and number of columns will be N into L plus M. Sorry, it will be different, not that one, so don't remember this. This is not the case here. Okay, this is the different, that is different. Okay, so in the code convolution code code in matrix method, number of rows will be number of digits in message sequence, that is L, right? And number of columns will be N into L plus M. That means such that matrix order is L cross N into L plus M. This is the generator matrix of convolution code dimension. So M is the number of flip-flops, N is the number of modulo 2 adders. So basically for the top adder we'll get some sequence, right? G1 G1 G2 G3 so on Gm plus 1, and the bottom adder will get this sequence. Okay, so what he is saying is, we'll write what we are saying, we'll write in a numerical, we'll understand. So basically in a generator matrix has found the output sequence and the input sequences, when the input sequence is 1 0 1 1, and the G1 G2 they have given, G power 1 G2 G power 2 they have given. So that is 1 1 1, and G power 2 is 1 0 1, right? So what is the message sequence? 1 0 1 1 1. So the length of message is 5, so 5 rows will be there, and G of 1 G of 2. So G of 1 has basically so basically there are 2 G's, right? That means N is equal to 2. Okay, and then that means basically there are 2 flip-flops. Wait, so there are 2 G's, that means there are 2 modulo. See, there are 2 modulo, that means two outputs, two modulo 2 operators. That's why we got two outputs. If there are three, we'll get three outputs, like that. So basically we got two outputs, that means two modulo 2 output, two modulo 2 adders, so that means n will be 2, and each g there are 3 bits, that means the m value. Okay, the number of flip-flops is 3, that's why you got 3. Okay, so from g we can so number of g's will tell you number of adders, modulo 2 adders, and number of bits in each, the number of elements in each g will tell you what is the value of m, that is number of flip-flops. Okay, so m is 3 and n is 2, so we can write it as 2 and also if so number of columns will be n into l plus m, so 16. So basically length is 5, right? 5 cross 16 table, this is a 5 cross 16. So basically 1 is not only single, okay, single and one is, this one is single, this one is separate. Okay, just for our understanding we write as like near to each other, but actually each individual is different only. So how to write this? So they have given, first we know the order, right? G1 of first one, and here 1 1 0 1 1, right? 1 from here, 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 like that we need to write 1 1. So 1 0 1 0, here 1, here 1, so 1 1. So basically the dimension is what, 5 cross 16, that means 16 columns should be there, but we got already 1 2 3 4 5 6, we got 6. So basically there should be 10 more columns, so all these columns should be 0 first all this will be zeros. After that what we will do, we just shift cyclically, and just basically we just shifted. Okay, cyclic shift, this will be coming here by 2 bits. Okay, we need to shift this by 2 bits, remember that, cyclically shift by 2 bits. So last 2 bits will be coming from, these 2 will be coming here, these 2 will be coming here, these 2 will be coming here, like that. So like that, how many times how many total rows should become? We have to come 5 rows, 1 2 3 4 5. Actually there is a mistake, actually only 5 rows will come. Okay, fine, up to here only we'll do, this is not there, so mistake is there. And then what we should multiply, this is the G matrix, that is generator matrix. We know what is the data that is given, we multiply this D with the G, the same procedure how we done for the previously, that is the code vector. So this is the code vector we'll get. Okay, so again what they are saying is, anyways this is normal this is an x modulo 2 only. Remember, even if you do this matrix multiplication also, we need to do modulo 2 only. That means if there is a here if the multiplication done here 1 plus 0, that means 1 XOR 0 we need to see. So 1 XOR 0 is 1, right? So that's why it is 1. Understand, right? So basically write in write normal numbers like that. Just writing commas is also fine. Basically we are grouping the two bits 1, like that. Okay, not writing comma also it's fine. So this is how we'll do matrix method. Okay, so thank you, this is the end of this session, this course ITCT. This is the end of this course. I hope you enjoyed, you learned out. So thank you for watching. Please like, share and subscribe to my channel.